Hello everyone. Today we would like to introduce to the project that's called Revert. Revert is a smart innovation sensor system that is based on increasing the Revert is based on a sensor system that increases the chances of recyclable materials. We think that the materials that we recycle are taken care of, but they're not in the bigger level. So we have created a system that could increase the chances of recycling more material and get good productivity of it. And also, I would like to introduce to the team of Revert.
Hey, so I'm Dylan Shell. I'm a recent graduate of the Mobile Applications Development Program here at St. Clair. And I just want to say I'm thankful for being at St. Clair because I'm able to be a part of a group like Enactus, where we can be a part of a project like Revert, and to attend events like this where we can share knowledge and discuss ideas with like-minded people like you guys.
And my name is Sahran and Dylan. I'm an electromechanical robotics student here at St. Clair College. I'm also involved in research and development here at St. Clair College, and I'm also an active member at the Enactus St. Clair Club. And then we, as in a team, are working in the Revert project since 4 months.
So I'm going to talk about the problem with recycling. So usually when you recycle, you have your plastics and you have your paper, and once a week it goes away off your curb. But what most people don't know is recycling's biggest enemy, cross-contamination. So what cross-contamination is the amount of unrecyclable materials mixed in with recyclable materials. And if that percentage of cross-contamination, if that exceeds 10%, then everything including the recyclable materials is sent to a landfill, sorry. And this is what happens to 75% of Canada's recyclable waste.
And we've also got some statistics from the internet, and then you can see the cross-contamination rates of contamination rates of the residential recycling. We can see that Toronto is leading the country for 26%, and Edmonton is at 24%, just behind Toronto. And then Vancouver, being a very large city, it's at 4.6%, so there's really good development for recycling in Vancouver, but there's a lot of progress to make in Ontario, as we can see in the chart.
So now you know the problem, and now we're going to introduce you to our solution.
So this would be the hardware the hardware system that detects the waste. We call it the reverse waste detection system. We have used an ultrasonic sensor that has a range of 400 centimeters and an accuracy of 3 millimeters to get accurate results of the height, to measure the height, how much the bin is full or how much empty it is. We've also used a Raspberry Pi microprocessor to get everything together, get every data, and then get an output, and also run the AI. We've also used a camera, a 5-megapixel camera to be precise, which gives clear images to us, and then we could run tests through it and then see if the added object is recyclable or is it a cross-contamination object.
And that's about Revert's hardware side, which is the sensor system. Now I'm going to talk about Revert's interface and data side. So once we get the images from our sensor, we would process it, and then we would compare the images with verified data. So that would be, if we got a picture of what the bin looked like, we can identify the unrecyclable parts, and then verify that if it actually is an unrecyclable part. And with that information, we can discover trends and patterns. And with those patterns, we can graph them and display them on an interface, like a user interface, which would be like a mobile app or a website where you can access the data. So now we're going to go through Revert's roadmap. We started with our initial concept. It was mostly research and finding what materials we needed.
Then the second step was sensor designing. So we went to different products. We searched for different cameras, different sensors to measure the height, to measure the weight, and then we came up with a good quality parts list, and then we made a good prototype in the second part of the project.
Next would be our interface design. So it would be wireframing, like a mock-up of the app. The front end, which would be the user interface, and then the back end, which would be the logic of the data and getting all the data organized and graphed out.
And then data collection would be the part that we are at right now. So we are collecting data from different bins, we have partnered with Devonshire Mall, and we're getting data from them that how people have trends in throwing waste away, how much people are aware of the waste, and then after collecting the data, we make a good, we can make and train the AI to get desired results.
Then after that, we're going to move on to our testing phase, where we're going to implement features, resolve issues, and then finally, we're going to move on to our controlled deployment. So once we're certain we have a decent prototype, we can deploy it to St. Clair at one of their bins, and then collect their data and move on from there. So some final remarks we have. Over the next year, we plan to fully develop our sensor system, fully develop our dashboard application, which is linked with the sensor system, make improvements based on feedbacks from our partners, and explore pilots within our community partnerships.
And we've always used this quote in Revert that we aim to make our shared efforts truly sustainable. Thank you for your time, and we will be open to any questions that you may have.
My question is, where would this system physically be located? Is this something that you would put on a recycle bin, or is there a certain spot you would bring the recycled material to?
Currently, we are on the phase of training garbage to the AI, and then after achieving that, we would be, like you said, we would be mounting it on a dustbin, and then we will have good lighting conditions. So we might use some lights, and then that would give an output to the user that it's using, that how much contamination that's present or not.
With this, one more question. Would this also detect when people recycle water bottles that still have water in them, as an example? Because I know that that's been brought up when we've done some volunteer events as something that they can take.
That's something actually, it's a good thing to consider, now that you mention it, actually, yeah.
Yeah, okay. Thank you.
So my question is, I know that we had discussed about dimensions and the accuracy of the dimensions, but is there something specific, maybe based on material? How do we determine materials using the sensor? So whether it be glass or tin or paper?
It's based on the image. So like we as in the human know what the object is like on the way it looks, we could train the AI that this might be a cup of coffee, this might be a cup of water, or just objects in general.
So you're going to be training the artificial intelligence based on this is a picture. So
yes.
The question I have is related to the deep learning algorithms. So I assume you're using deep learning instead of AI, but are they running on the Raspberry Pi somehow? Or are you going to ship them to a server and then send the answers back?
So yes, all of the data is collected in real time and then is processed in the Raspberry Pi, and then it is sent wirelessly in the mobile app that we're about to develop in the future. So everything is integrated within the processor itself. Yes.
So the Raspberry Pi should have enough power to process the neural network?
Yeah, we are planning to add lithium polymer batteries and then have backup batteries just to make sure that we don't run out of power. And then we also have like new versions of Raspberry Pi that are faster than the older versions, so we can always use them. Thank you.
you presented some data with some percentages in terms of some provinces do a better job at this than others. I was just curious, did you do any benchmarking of some of the, leaders in terms of recycling? Like I noticed St. John's, Vancouver, they were, much less. Any benchmarking, any lessons learned from those locations that helped in deriving this project?
No, nothing yet. No, from those locations, no.
Hi, my question is, so once your technology detects the cross-contamination, what will happen after that? Does that get rejected? How does that whole system work? Or what's the thought process you have on how that could work?
If it's contaminated more than 10%, or maybe if it's near than 10%, the user will know that this product will be waste after, you will have certain amount of more contamination. So it's based on the user, so they can judge that if they need to throw it in the recycle or get just the results of the contamination rates. So we're getting percentage results right now.
So there's some kind of feedback to the user to say,
Yeah.